Hello, everyone. Welcome. It's good to see you all here. My name's Danny Quilton. I'm the CTO and co-founder at Capacitas. And this is one of our many events we're going to be running over the next few months with technology leaders in the space around cloud, and particularly high-scaled implementations around cloud. And to that end, we're very fortunate today to have Mike Hewitt with us, CTO at the data communications company, DCC. Mike, how are you doing?
Danny, I'm really good, and it's great to get a chance to come and talk about some of the great things we're doing in DCC.
Yeah, listen, thanks for coming along. It's great to have you. And I guess, there's a few people I saw on the attendees who are outside of the UK. So probably to start with, tell us a little bit more about DCC.
Yeah, I guess, Danny, where do I start and how long have we got? I started at the beginning, DCC, Data Communications Company. If I go back, I joined DCC back in August of 2020 in the middle of COVID. I hadn't heard of the DCC, but given my background, I thought it was something to do with data centers. You start looking at what are we doing in the UK to digitize our energy system? Well, we have this thing called smart meters. Smart meters connect every home. Certainly we'll be connecting every home. And the DCC is the organization that runs the technology platform that sits behind smart metering. I thought, wow, that sounds really, really exciting. I need to know more. By circa 2030, I guess, 30 million homes in the UK will be connected to the digital domestic energy spine. A big part of that is the whole decarbonisation journey. And we're a fairly unique organisation. I use these words cautiously, but with privilege. We are, I guess, the regulated monopoly that operates under a license to run smart metering on behalf of UK PLC. Capita is our shareholder. They are the license holder. They secured the license back in 2014. So we're now 11 years into that journey of smart metering. So with that, I guess, what do we do? I talk about the technology stack. So we own the contracts with our CSPs. We define the vision and the long-term roadmap for the platforms that underpin smart metering. It's a complex ecosystems. I say we were founded behind a license back in 2013 by what was DEC at the time. DEC was one of the government departments. DEC was Department for Energy and Climate Change, I think it was at the time. It then became BEIS, the Department for Industrial Energy Strategy, and it's now DESNZ, Department for Energy and Net Zero. So we have a number of key stakeholders around that. The government department that owns the business case, and not insignificant business case. It's around about a £14 billion business case for smart metering. So I guess that's who we are. What do we do, Danny? You started on that. We spent the last 10 years building. Part of that is building for smart meter rollout. Rollout's never complete. We have a 15-year device that will sit in every home. And by 15 years, that's sort of life of it. So you think 30 million homes, 15-year life, rolling out about 2 million a year. It's a bit like painting a bridge. By the time you get to the end of it, we roll out the 30 million. We've got to start swapping out the first ones. And behind that, we need to maintain the complex technology platforms that sit behind it. So I guess that's what we do. The custodian of smart metering, the digital spine behind smart meters. I guess that's who we are, Danny.
Yeah, that's really useful intro, Mike. I guess touching on the scale side of things, growing out to 30 million meters. Can you expand a little bit more on what that means in terms of the volume of traffic or messages that you're carrying?
Yeah, I'll start at the beginning, I guess, Danny, which is rolling out to 30 million homes. That is a long journey because that requires an engineering visit to every home. Part of that is we don't roll out the smart meters, but we own the technology that will go into the home from a comms hub perspective. So I guess that's the end point of the network. Then onto that will go a smart energy meter. Onto that will also probably in many homes will go a smart gas meter that connects via Zigbee, the network in the home. There will be things like the in-home displays or prepayment devices. So that's the start. It's the equipment in the home. We have to make sure is connected and remains connected. And I guess as we get through the conversation, Danny, I know we'll probably come back to the world of SMETS 2 and the world of SMETS 1 and some of those challenges. Behind that, at our inception, we had 5 technology partners. a proprietary radio network in the north, Arqiva Long Range Radio. Back in 2014, there's some really good reasons why we didn't use the cellular technologies that were available, primarily around coverage. A 2G, 3G radio solution that was delivered by, was Telefonica at the time, now Virgin Media O2. We had our core data services platform, our DSP. That's really the heart of the solution that's been deployed. That maintains the integrity, it maintains the security. It's a security model that's been, I guess, implemented with a lot of support from GCHQ as it was at the time and maintained by NCSC. So we're uber secure. We are today, we are air gap from the internet in many ways. We talk about security being at the heart of what we do. If we became an attack vector, you could turn off energy to every home in the UK. So security is really, really important. So the security model is uber tight. Around driving consumer confidence, so how do we encrypt and secure that data? As DCC, we can't see your energy consumption data for an individual household. We wrap it up and then we transport it and we give it to those that are authorized to see it. We maintain today around about 600 million plus encryption keys. So that's our PKIe infrastructure. Another part of what we maintain. And then we have a little application within that suite originally of those 5 service providers that was pass and correlate. So when we get a message to do something that's critical, that critical could be turning load up, turning load down. How do we ensure the integrity of that message? So we get the message, we check it, we validate it. We then send it back to the originator so they can confirm that, yeah, it was me that sent it, and we send it back again. So at our inception, 5 fundamental service providers, that was back in 2014. Roll forward to 2025. Today, we're at 17 fundamental service providers. We've added in a 4G network, we've added in change of supply, we've added in faster switching, half-hourly settlement. All of those are driving more and more messages onto our network. We're circa halfway through that journey today, a little bit over. We carry close to 4 billion messages a month at the moment. Everything from meter reads to tariff updates to prepayments to DNOs reading voltage and consumption data and other use cases that are coming through. Wrap around that, probably close to another, same volume again, another 4 billion alerts. That could be anything from a power outage alert for DNOs so they can get early notice of where homes don't have power, or it could be meters operating in credit mode. Lots and lots of alerts, lots of data, and that is only going to grow. Only this week we're talking about some of the future use cases for smart metering. As we go on our decarbonisation journey, and we like to refer in DCC, we're a big part of saving the planet. If we're going to decarbonise our energy system, it's going to be built around renewables. And the great thing about renewables is when the sun shines and the wind blows, it's zero marginal cost. But you've got to make sure you're using it. So, in the future, time of use tariffs or tariffs that said there's a surplus of sunshine or a surplus of wind available, send a message into the home to use some of that energy. Those are all some of the future use cases that will be driven behind the smart DCC platform.
And some of those use cases you talked about earlier, I guess, do you want to maybe expand on the sort of workload profile you see? So you have peaks, don't you, in particular message volumes that you guys need to handle those peaks. Do you want to expand on that?
Yeah, and that's going to continue to evolve for anyone listening. When a smart meter in our inception was, I guess, designed to read the meter twice a day. If you go back to sort of 2014 times, we didn't have things like flexible tariffs and time of use tariffs. Today, many times, we're now reading that meter 48 times a day. Now, that doesn't mean we dip in and read it 48 times. A lot of the retail energy suppliers today will do their meter reads between midnight and sort of 4 or 5 a.m. So overnight, they'll pull down those 48 half-hourly readings that supports your billing. DNOs are starting to look at getting more access to data so they can start to optimize how the network is being used. We're certainly aware of a trial that was carried out back in, I think it was 2021, 2022. It was called BEAT. It was this Boston Spa energy efficiency trials, where DNOs are looking at, by regulating the voltage that's supplied to a home. We talk about 230 volts, 240 volts, European harmonization. But by making small changes for 2 or 3% of what that voltage is in a local area, you could see savings being passed through to consumers. So that was a trial that was done. It's ongoing. but DNOs being able to get real-time access to voltage readings, really, really important. Optimizing the grid in the future. Feed-in tariffs, so reverse feed-in back from your home as you start exporting energy back into the grid because you've got surplus renewables in your home. Another use case, the power outage alerts, extremely important, not only from enabling DNOs to respond to significant events, but homes, at-risk and vulnerable individuals who lose energy to the home, the DNO getting that alert and being on the front foot and saying, hang on, this is a vulnerable individual. The power's gone off to that single home. There may be something local on the network, enables faster response to them. So as we shift from real-time, moving to a real-time energy system that responds in a dynamic way. In the future, when we look at, we're going to electrify society, we're going to electrify transport, the role of EV charging. When every home has an EV charger and they all come home at 6 o'clock and they all plug in at the same time, how can the grid make sure it can meet that demand? Well, proportional or standalone load control or load control signals being sent over the network to control so everyone gets a fair chance to charge their car. We're part of a dynamic and future energy system, all unlocked by a secure messaging platform, a secure smart metering infrastructure that underpins and sits behind UK's decarbonisation journey. And it's something we should be really proud of. We spent a little bit of time around thought leadership, and I know Danny will talk about sort of my role and DCC's role, but starting to share what we're doing in the UK with other distribution network operators around the world. We spent a bit of time in 2023 and beginning of 2024 with one of the distribution network operators in the Netherlands. They were looking at, what's your model? Before today, they embedded their comms into their meter. Meters tend to have a 20-year life. Comms tend to evolve faster. So they've gone for a modular comms hub. So today our comms hub in our SMETS2 system sits on top of the meter. We can take that comms hub out and upgrade it to a new technology without having to take the meter out. So sharing those ideas with other organizations. Some of my team have joined the European Smart Metering Interest Group. What's going on in Europe? What can we learn and what ideas can we share? So really important that we share ideas as part of that journey, Danny.
Yeah, and this might be a difficult one to answer, but do you see, I mean, you talked about, similarities with your sort of counterparts in the Netherlands, but do you see more broadly other industry sectors where, there's a lot of similarities between the scale and the challenges that you need to meet in the cloud?
Well, we use, before we get onto the cloud, I guess, any similar challenges. Well, IoT, the Internet of Things, or IoE, the Internet of Energy, connected things, is something we talk about. We're all aware of, many of us touch around IoT networks. They tend to scale. Vehicles are a large IoT network. Sensor networks can be a large IoT network. But in many ways, I think the DCC has the opportunity possibly to be one of the largest IoT, IoE networks anywhere. Unique set of challenges in the UK. Once we get to that rollout, we talk about 30 million homes being connected to our network. Upwards today, our forecasting, probably over 150, 160 million devices connected onto that network. We don't just have a energy meter in the home. We won't just have the gas meter in the home. There will be prepayment devices, in-home displays, proportional load controllers, or potentially other things that might connect to the network in the future that may not just be energy related. Certainly within DCC, our role is not to innovate. Our role is to enable innovation, markets to innovate. We've had everything from healthcare use cases. Could we connect one of the bizarre use cases was, could we connect a blood oxygen sensor into the DCC hub in the home? Your hub is uber secure. Every home will have one at some point in the future, not just those homes that have smart energy services. Every home will have a comms hub. Not every home will have broadband. So if we could send a patient home with a blood oxygen sensor that could connect securely to your network and transmit data to the hospital, does that enable early discharge of patients from home? Well, great use case. If the comms hub is there, why not reuse it for secure connectivity? So those sort of things will come up in the future. So that the in-home edge of our network, the in-home, the comms hub, the secure endpoint in the home being used for other things that unlock value from a network that's already existing that is uber secure, that consumers have confidence in, and that does avoid digital exclusivity. As I say, not every home has broadband, but every home might want to get access to connectivity for other use cases. It's going to be really important. And so part of that is making sure our platforms can scale, and Danny will touch on, I know we'll get into some of the cloud transformation journey as we go through our conversation, but making sure we truly become an enabler for the future, not an innovator. We have connectivity that unlocks innovation, but keeps security, resilience, and scale at the heart of what we do.
So before we dive into that on those topics and how the cloud is going to help you on those questions, perhaps, given you've set the scene there, in terms of you're quite unique in terms of having these 17 key service providers that are helping you to deliver this platform. Tell us a bit more about your role specifically in the CTO office.
Yeah, great, Danny. As a CTO, I cut my teeth before here around the rail industry, again, highly regulated. Again, rail and innovation are not two words I would generally put together. But certainly, as Panasonic's transport CTO in the UK, we started to look at some of the great innovation ideas we could bring to rail to make a better passenger experience. That was everything from, it's still the bane of my life, is improving connectivity on trains. We had some great ideas around that, and we certainly made some differences in that. But bringing other technologies in, everything from video analytics. So when you're a CTO, you generally get a 5 to 7 year window to look at from a technology domain perspective. And boy, when you walk into the DCC and realize I've got the 15 years back we need to be thinking about and maintaining, because you can't just go into every home in the next year and swap those devices out. We've got to maintain them. I've got the next 15 years forward we have to be thinking about. So today that takes us out to 2040. In fact, some of the decisions we've made, and certainly in my time here, has been around 2045, and we're now starting to talk about 2050 and beyond. So as a technologist, boy, is that a privilege to have a 30-year technology window that you get to look at. Come with its own set of challenges around, certainly around some of the technical debt and legacy that we have to be considerate about. We've got to be considerate around the business case that supports smart metering. In many ways, and I talk to my team about this, as DCC, we sort of reach out and we take £20 out of every single home on a yearly basis. It costs over £600 million to run the technology platforms that sit behind smart metering. So as custodians of that, one eye is always on, are we doing the right thing for UK PLC? Are we conscious of consumer benefits of smart metering? And are we conscious of the customer impact? Our customers are the energy retailers, the distribution network operators. There will be other users that come along and want to use the platform. So we've got to be mindful and very customer-centric around that. But as a CTO, for me, it's around having a very clear technology strategy that our customers have confidence in. Again, it can't just be about 15 years. When do they have to start swapping comms hubs out? What is the next technology platform we will be operating on? We use the word 4G within part of a lot of the roadmaps that I'll talk. Our 4G technology platform went live on the 2nd of December last year. We will now start mass rollout of those 4G devices. Everyone's saying, why 4G? Why not 5G? Or why aren't you thinking about 6G? Well, in fact, we have to think about, at the time, when we're making the decisions back in 2021, 5G is not pervasive connectivity across the UK and still isn't today. It will continue to evolve. So what we did is we worked closely with the mobile network operators, with component manufacturers, and it's around an LTE solution. It's an LTE Cat 1 that will evolve to, as part of the evolution of the LTE standards, making sure that's part of the 5G standard and part of the 6G standard. So technology strategy is really important. As I say, unlocking innovation for our customers that we have today, retail energy operators, the DNOs, or customers we may have in the future, going to be really, really important. But where we start to bring innovation is it's around providing clear technology direction across our fundamental service providers. And when I walked in 2025, we have very little cloud estate in our ecosystem. An awful lot of what we had was on-premise infrastructure, and we still do today. So servers sat in data centers around the UK, and all of our estate sits in the UK. Some of our license requirements around protecting UK PLC. So we've got a mix of on-prem, private, cloud. I think the word cloud is often overused. It's still servers sat somewhere. We have a large HSM estate, our hardware security models that protect and encrypt all the service that we offer. A lot of those sit on-prem today. So how do we start to rationalize and get almost common design patterns across the estate without getting any lock-in? As custodians of smart metering, one area that's really sensitive for all of us is how do we make sure we don't get locked into any single service provider that we can't extract ourselves? So cloud portability has been a big part of what we've been talking around, ensuring the resilience, changing some of the availability models. Doesn't matter what, we have a, certainly where I am, it's around, I guess, resilience first, smart metering system that's always on. Today we often have to take our smart metering systems down for 4 hours a month to do a lot of our maintenance and patching. For me, that doesn't feel like a very smart energy system in the future if that is not available. So how do we drive ourselves to near zero downtime? How do we understand the impacts of availability and ensure we've got the right levels of resilience? Site resilience engineering versus business continuity and disaster recovery, self-healing networks. The fact that when you've got 15 fundamental service providers, they've all got different requirements to maintain the network. That could be everything from maintaining a base station in the CSP network or in our long-range radio network to maintaining their core infrastructure or any one of our service providers. And then how do we get consistency across? There's no point having 5 nines at one part of the infrastructure when another part's sat at 3 nines or 2 nines. So getting consistency across there. So for me, it's been around, and I know we'll touch on this building, Danny, as we go on that cloud transformation journey. I've sort of been clear, which is around don't lose the skills within our organizations. We are an engineering function. I've got to build that cloud center of excellence that understands and holds the accountability for the decisions we're making on behalf of the consumer, ultimately, because we're spending consumer money. So owning blueprints, having the right people, keeping the accountability, and understanding when is the right time to change. For me, we've got to leverage the value of the systems that we built, but work out what's the optimum time to transition to something else.
Yeah, I guess so just to take a step back, then when you're looking at the sort of primary reasons for moving to the cloud, resilience comes out loud and clear. When you've been looking across the other dimensions of, say, cost, you mentioned people there, sustainability, scalability. Was it all of those, or was it primarily resilience and then the others were supporting aspects in the business case?
Oh God, where do I start? It's a great question to drill into, Danny. And it's one of those conundrums I think many organizations have to deal with. And there are a lot of drivers to the cloud, and there's a lot of great use cases for transitioning to the cloud, certainly around the flexibility and scalability. One of the big challenges we have is around our testing governance that we have to maintain. We have something like 35,000 device model combinations of different meter types with different comms hubs, with different prepayment displays, and making sure whenever we make a change, we don't break anything. So as you can imagine, testing is incredibly complex. And we do an awful lot of testing. We run through a lot of regulated testing, what we call our SIT testing and our UIT testing, so our systems integration testing, our user integration testing. So users want to test on our systems. We have to test on our systems. Our 17 ecosystem providers have to test on our systems, testing different releases, maintenance. So maintaining test environments when you've got to build to a percentage of the overall network. We can't performance test at scale every single one of those ecosystem partners when they've all got to build 10 on premise. It gets really, really expensive. Yeah. So, we do cut down versions of our production environments, and that presents a set of challenges. If everything was in the cloud, I could turn it on, I could test, and I could turn it off. Today, a lot of my legacy testing is 10 on premise. So one of the real benefits we're doing, we're going through a number of cloud transformation journeys at the moment, but our big one, our DSP, being able to have production-like test environments that can test at scale, and that scale could be upwards and will be upwards of 30 million homes connected to a network. So a billion messages, potentially a billion messages a day going through those test environments. They have to scale and they have to be fairly representative. So the ability for us to be able to turn those on, do our testing, our regulated testing, and then turn them off when we're not using them will be really, really important. In the future, our production systems, the usage patterns are going to change. As I said today, an awful lot of certainly our service users like to read the meters overnight. And some of that's driven by install and commissioning during the day that don't want to impact that. So we see real traffic peaks between that sort of midnight and 4 a.m., 5 a.m. We see peaks at the times of, there's one we're all leaning into, and we all heard the news last week from our regulator about price caps, when energy price caps change. So on the 1st of April, we see a lot of meter reads wanting to be done overnight and all the tariff updates wanting to be done. Now, in the past, it was really interesting. One of the dynamics we have seen change, which was industry was quite slow to do tariff updates when prices are going down. When prices are going up, they want to do tariff updates really, really quickly. So those all come in sort of overnight. So the ability to be able to scale our platforms to deal with price increases, and hopefully in the near future, we see prices coming down again. And certainly when prices come down, I want my tariff updates to be done really, really quickly. And that has a huge impact on prepayment customers. Prepayment customers are, usually some of the more vulnerable in society. So they want to achieve tariff updates really, really quickly. So being able to turn on additional capacity when we're fully in the cloud will be really important for all of those evolving use cases. And, being able to predict demand and say, right, we know that, power outage alerts, if there's a storm coming, making additional capacity available to take more alerts so we get them through quicker. All those things are what some of the real benefits from cloud, as are the ability to, common blueprints as well.
Yeah, that sort of high peak to average workload demand pattern you guys have is obviously ideal for the cloud, and just trying to draw parallels elsewhere, because people might be listening to this and say, well, DCC is so unique and some of the things we're talking about here are just totally unique to DCC, but I don't think that's the case. We do see trading firms, for example, where they have peak to averages of 20 to 1, and again, when you've got those kind of workload patterns, you can really avail of the scalability up and down in the cloud. I should have said, actually, while at the beginning, look, we're trying to make this as interactive as possible. So for you guys listening in, just ping questions into the chat, and we'll answer them as we go through. In fact, one's come through already. So question for you, Mike. DCC is both large in scale and high in complexity. How is this conflict being addressed?
I don't think those two things are mutually exclusive, I guess. Complexity. As CTO, and certainly when I look at my engineering team, and I lead a team of about 150 committed technology experts that are trying to, I guess, decrease some of the complexity in smart metering. Now, some of the, we have some complexity we've had to lean into and address. Some of you will be familiar, the first generation of smart meters, called SMETS1 in the UK. On an awful lot of stories around when you change supply, your smart meter would go dumb because your energy supplier that you shifted to could not talk to it. So some of the complexity we've had to unpick is, how do we make those dumb meters smart again? So over the last 4 years, the team has been building an integration capability, which only added to the complexity of bringing all those smart meters into our SMETS2 system. So we got them to be smart again. So that added complexity. As we move forward over time, those deep domain experts understand the complexity behind smart metering. It's everything from the security model we operate to the legacy meters that we have to continue to support and will need to support. Some of these first generations would have been installed around 2010, 2011, 2012, maintaining those to the back end of this decade and potentially early into the next decade, so we keep them alive. So for me, it's around, a big part of that is, get into which is that engineering team that I've got as sort of custodians of smart meters that have to understand some of the complexity. How do we address with knowledge transfer and knowledge retention? People will come and do their tour of duty in DCC and they will leave and go elsewhere. They take some great knowledge with them of addressing complex systems. We spend a lot of time around, we use the word systems engineering, understanding how all of these different systems bolt together. But over time, how do we start to simplify some of those systems, whether that's looking at interface standards, standardizing some of the connectivity infrastructure that underpins what we do, common firmware across devices. We've got, and across some of our meters, we have an estate that they have, the last 27 firmware variants are still live in the field. So given that we're now at scale, and given we are, as trusted domain experts around smart metering, and now, certainly from an engineering function, is how do we start to drive industry? Say, having 27 firmware variants out there is creating more complexity. We need to drive to have an N-1, N-2 out there. So that means I've got less testing to do and less risk when I make change. So complexity, to me, it's around understanding your role as custodians of smart metering, taking that role very seriously, and it's a privileged role. And I talk about that sort of privilege as CTO leading that team. How do we start to simplify? And some of that, it's standards-based architecture, avoiding cloud lock-in, a common cloud blueprint, common cloud implementation models, shifting to more of a microservices away from monolithic architecture. So when we want to change things, they're smaller and we have better understanding. Then around the scale, scale gets a little bit easier, I guess, when you have common blueprints. And I think cloud really does start to unlock some of the complexity at scale, but our ability to scale even easier. And we spend a lot of time, we touch on it. Cloud portability is not without its challenges. We've made a decision, we'll sort of probably stick with a sort of container level at the moment. So it gives us a greater ability to avoid lock-in in the future. And across our ecosystem today, we have large parts of our estate operating in AWS, and we have certainly a growing Microsoft Azure estate. There are benefits from having different parts of the ecosystems across those two estates from a resilience perspective. When you've got core platforms in Azure and your monitoring platforms in AWS, if one's not available, you still get visibility of the other one. So those sort of some of the decisions we start to make, shifting a little bit more to that sort of resilience engineering. A lot of when we got here was about business continuity and disaster recovery. Well, how do you avoid those disasters in the first place? And there is a lot of visibility around smart metering. Anyone that was part of, we weren't impacted by CrowdStrike last year, but certainly when the cloud does go down, smart metering is part of it. Certainly an awful lot around media not being available, the ability to travel being restricted, puts us all on a bit more of a level playing field, I guess, when there is pain from the large-scale infrastructure providers. We can share some of that pain, I guess, rather than just being purely focused on smart metering not being available.
Yeah, I just want to pick up on the you're talking there about the different cloud providers, and I've had this question come up a few times in other conversations. Do you see any workloads that should not go to the cloud?
Well, great question. I guess there are some things that I get nervous about. So we talk about our security model, and we probably as DCC probably run one of the largest hardware security module estates certainly in Europe that protect the infrastructure. We have when things are in the cloud, it's hard to walk into a data center and pull those hardware security modules out. So one of the things we're looking at the moment is they're our crown jewels. They secure smart metering. Those are probably one of the things that I want to keep on-prem ourselves and always have access to. They are our crown jewels. So how do we then replicate those keys in cloud-type architecture? And we're certainly seeing some of the importance behind it. Some of the relationships you have to have, and again, that's another one of the privileges we have in Smart DCC is the strong relationships we have with the likes of AWS and Azure, and growing relationships with the likes of Google and some of the private cloud providers, whether that's someone like DXC in the secure private cloud or someone like Civo in the UK around their sort of on-prem and sovereign cloud capabilities, is having strong relationships, understanding what their roadmaps look like. So talking to Azure and AWS around cloud HSMs, being able to define and understand what their roadmaps look like, what the implication will be on DCC is really, really important. So again, I talk about some of the privileges of some of the challenges DCC has, but also some of the privileges we have because we are part of, we're deemed to be critical national infrastructure. What does deemed to be critical national infrastructure mean? I guess we have to conform to all the CNI standards without necessarily being able to have the ability to pay the premium price for it. So it's a challenge. So we underpin the digitization of the energy system. It's our data that is the domestic energy landscape that's going to be critical to the whole national grid journey, the whole NESO journey, or how you balance the grid.
Yeah, that's really useful. And you mentioned earlier on the conversation around technical debt. And look, every organization that's been around as long as you guys will have technical debt. And we're working with a lot of banking finance companies at the moment, and obviously systems have been engineered over 20-30 years, have technical debt. Where do you stand on the technical debt question in terms of in context of the cloud migration? Should we be addressing this technical debt before we go to the cloud, or should the imperative be let's get to the cloud quickly and then we'll figure out the debt later on?
Yeah, I guess, Danny, it feels many ways, and I frustrates me to say this as a CTO, but sometimes the pace that we have to move at is absolutely glacial, and part of that is because we're making some big decisions. Our 4G business case was around about £2 billion of overall investment, so you've got to go through a pretty robust business case process for that. Some of that's driven by because while we're not a government entity, we're a pseudo-government entity, we have to comply with what's called the HMT, the Magistrate Treasury Green Book business case. And that requires us to present a series of options from almost do nothing to do everything and everything in between. Generally, there's about 5 options that we'd like to take forward, and then we'll take a recommended option forward as part of that sort of ultimate journey. So some of our gestation periods are quite long, sort of 3 to 5 years, I guess. For me, what's critical, though, is when we talk about technical debt, do you understand what it is? And do you have a robust, I guess, register of all that technical debt? Then how do you start to put a risk profile against it? And we spend a lot of time with our organization, certainly within my technology team at the moment, which is, I guess, from a risk management perspective. Risk is not about governance for me. Risk is about being able to work out what your priorities are where you've got technical debt and say, right, I know what the list looks like and I know where the biggest risks are. Then I overlay that my commercial pipeline. That says, when is the right time to do something? That'll be driven by either a contract is coming to an end, so you've got a real chance to intervene and deal with it and get some of that debt on the map, and we're going to look to eliminate some of that technical debt. It might be driven by the solution is getting really cost prohibitive to keep running, so we need to provide an intervention under that current contract to mitigate some of it. Or we're going to have to be aware of it. We're going to have to be able to report it into our business that says we can't do anything about this for 3 years, 4 years, maybe further out than that. Yeah, and I'll give you an example that's really firmly in our state today, which is around 3G sunsetting, a shift to 2G only networks. There is a technical debt there that we are operating on a 2G network out until 2033. The UK government announced its 2G sunsetting timeline. No surprise it was 2033 because that's when our current contracts with our CSPs end. So we've got to work out how do we carry and manage the risk of something like 2G network for the next 8 years. Just being aware of what it is. We work really closely with all of our fundamental service providers to understand what risks we're carrying. So as message volumes go up on a 2G network, how do we deal with that? Well, we have to optimize and manage traffic effectively. Almost like no difference to any telco network has to do today, which is prioritization, quality of service, and optimization of networks. Some of that elimination of technical debts could be things in the future where we provide data caches, so we hold data and then forward it on rather than getting the same message multiple times. One of the challenges we talked about message volumes today, at our inception, Danny, I think I touched on it, which was read a meter 48 times a day for your energy retailer. Well, your DNO now wants access to that, so that we carry that data again. There are now other users driven by innovative consumer products coming to market. The Loop and Hugo apps that provide you insights into your energy consumption. They want access to that data, so they're now going to pull it. Half-hourly settlement, which provides half-hourly data for balancing and settlement of the wholesale energy industry. They want access to that data. So we've got to continue to be aware. We've got to work with our market providers, and we've got to look at really through, I guess, effective risk management, being aware of what that technical debt looks like and where do you need to prioritize or where do you need to just be aware of it so you're managing it. And as a pseudo government entity, operate under a license, highly regulated by Ofgem, if nothing else, making sure you've got the audit of where your debt is so you know what you're holding.
And then you can, I totally agree. When you understand that risk log, and then you can marry up risks being mitigated to particular refactoring or cloud adoption, then that's really powerful. Well, I guess just on the cloud side of things, I mean, you're going through the journey at the moment. What do you see as the key success factors to cloud adoption?
Key one for me, Danny, is going to be around, as part of our journey, we come under an enormous amount of scrutiny around how we spend public money, as we should. It's a privilege to be in the position we're in. I say we're a regulated and licensed monopoly. So against that scrutiny, today we have to provide a 3-year charging statement. So being able to forecast our pricing and our costs out, over the next 3 years is really, really important to us.
Right.
Now, when you've got fixed cost of infrastructure, that gets quite easy. Doesn't necessarily deliver the best value for money, because whether it's sat there idling or working at 80% or 100%, you've got that same fixed cost. So that gets quite easy to do. As part of our cloud journey and part of that cloud transformation is going to be around the ability to be able to turn things up and down. But you have to be, we have to be able to provide predictable costs around that and forecast those costs. So for me, whether I want to use the word FinOps, but around our cloud team, our center of excellence, is making sure that we can provide some degree of predictability about those costs and forecast those costs in an accurate way, but also be able to realize the benefits as we move forward, or be able to use cloud infrastructure and be able to turn things off. So almost that cost not to exceed, but we're working really, really hard to drive costs down when we don't need them. Now that's going to challenge our forecasting model in the future, taking a regulator who may or may not have the right technical expertise, being able to be really strong storytellers. I use the word, when I talk about CTO, you've got to be many things nowadays as a CTO. It's not just about the technology anymore. In some ways, I call it the chief translation officer. We have a complex stakeholder landscape to deal with. So how does me and my team articulate in a way that the technology decisions we're making and what that will mean for industry from a cost savings perspective? We have to be a translator, and translating that to a regulator will be very different to translating that to our government department. Very different to translating that, less different now, but different when talking to retail energy providers. Some of those, it's great. Some of those retail energy providers are very much on their transformation journeys as well. So they are becoming much more technology driven. Certainly with some of the disruptors that enter the market. Certainly the one big one at the moment with the big pink squid-looking thing is, has been a real disruptor and really looks to use technology platforms and wants to understand what our future technology platform and landscape looks like. We talked to DNOs around our cloud transformation journey, and this is a real challenge from a critical national infrastructure perspective. How do we make sure we don't all do different things? So how do we share knowledge? How do we share insights? So working with one of the DNOs around their cloud blueprint, a lot of synergies to our cloud blueprint. So we think that we're doing a good thing and they're doing a good thing. What we don't want to end up is, 15 different flavors of cloud implementation by the DNOs doing something different to the retailers that are doing something different to DCC. So starting to have those private level conversations.
Yeah, I think and it must be tough in the current climate with energy prices rising, everyone's bills rising. That focus on value for money, and I think looking in at you guys as an outsider, I think that one of the biggest steps forward has been the ability with the cloud to have transparency of cost, and the ability you guys have now to marry up demand data with cost data, and you can draw your conclusions from the behavior between those two different data sets, whereas perhaps in the past it wasn't as transparent.
Yeah, and Danny, it's a great point. And it's as an organisation at scale and complexity, data will be king behind all of that. Back in certainly when I joined, it was somewhat embryonic back in 2020, which was our technical operations centre. If you come from a typical telco background, you have a network operations center, you see how your network is performing. We were started on a path of our technical operations center. We started to mine data and pull data in from all of our fundamental service providers, on the performance of network, on the performance of service requests. Now, when I look at the just the value of the data that we have available to us in DCC to be able to say what are network patterns, where is demand occurring, what type of service request is driving demand. If you've got a certain meter, PP mid, IHD combination, does that drive problems into the network when they're doing install and commissions? How are our cellular service providers and our long range radio service providers performing? The richness of that data that enables us to be able to effectively, one, run our network, two, optimize our network, and three, we'll be able to predict that what the network usage patterns will be in the future will be invaluable to us. You know, we all know data is, we talk about data as being the new oil. Data will really play a pivotal part in us being able to optimize that network in the future. So we drive down the cost of running DCC, and we all, you know, that's part of the journey we're on, which is, you know, our cost should not be increasing, our cost should be reducing over time.
Yeah, I mean, we always say that, like, you know, as you scale in the cloud, you know, your cost should be falling, right? And
absolutely,
we see that with the cloud providers, you know, between 10 and 15% a year price performance improvement. So, you know, if your demand is staying flat, your cloud cost should be falling year on year. It's a really good point. I guess how do the people outside of technology view the cloud? I'm thinking about the sort of business units in DCC, and then those other stakeholders you talked about, the DNOs and government. Do they have the same enthusiasm? Do they see the same potential, or is it just a technology step change that is secondary?
Yeah, again, there's a number of things to unpick around all of that, which is, you know, we've been taking Ofgem, the regulator, through, you know, part of what we're calling our cloud framework. You know, today is DCC. We don't design anything, we don't build anything, we don't run anything, but we have all of the accountability for designing, building, and running the smart metering network in the UK. So, you know, that comes with the first set of challenges. So, to our fundamental service providers, they all go and buy cloud differently. They all go and implement it differently. You know, so whether I'm, you know, Accenture will have a pricing for the ECOS service that they operate. Our DSP, our, you know, CGI will have a different framework for the cloud costs that they operate on our behalf. Now, I could go through all of our service providers, and they'll all be doing something similar. You know, we keep saying, well, hang on, why can't we have almost that framework that DCC owns the procurement relationship with the cloud service providers, and we can aggregate those costs? Now, again, that's, for me, that's not an overnight change. For me, that's right. We've got to get the framework in place and understand being able to predict what our usage and consumption is going to be over the next 3 to 5 years. We then need to have the conversations with the cloud providers, and that could be anything from the hyperscalers to some of the secure private cloud providers we operate on today, so we can predict our costs. We can then put a framework in place that says, we think if we get a consolidated purchasing agreement in place, we've probably got pretty good buy-in rates with our cloud, with the infrastructure providers, hyperscalers or private cloud providers. And then and only then can we pull together a business case that says it's better if we buy it direct as DCC. Doesn't remove from our service providers any of the accountability for running the service, but what it will do is drive costs down of running underlying infrastructure, because we're implementing it in a common way. We can observe it in a common way. We can pay for it in a common way. And that's a real balance we've got to get, which is can't take accountability off the service providers. They still have to run it on our behalf. But we believe that we can drive cost savings into running smart metering in the UK. And those cost savings will be significant when I look at our underlying, our infrastructure costs are circa £400 million a year. That's not cloud costs. That's across all of our infrastructure service providers.
Sure.
That's everything from our CSPs. When you're operating 20 million mobile connections, you do the math on that multiplies up quite quickly. The data rates, the service that sit behind it. But there is money to be saved if we can aggregate and implement cloud in a common way and sort of consolidate those purchasing agreements while balancing accountability and responsibility.
There's parallels there with private equity. So we work with a few private equity firms, and they have relationships with the hyperscalers at quite a senior level, and then the portfolio companies they've invested in all use the same hyperscaler, and the private equity guys drive reductions in cost by directing all of the portfolio through one provider.
Yep.
So yeah, interesting parallels there.
Yeah, but I guess anyway, with that one, at least they can make some of their own decisions. If they want to decide to do something, they can do it. Again, I talk about, as our role as DCC, as our technology team, and now part of our translation journey, we've got to cement the why with the regulator, the how with all of our stakeholders, and those stakeholders could be anyone from, we operate under two codes, the secure energy code and the retail energy code. They have a complex set of stakeholders we have to take on the journey. They're generally representatives of across the retail suppliers, across the DNOs. So we have to take them on that journey on why we're going to do it. And then behind that, we have to build the business case up that shows the value for money while balancing that cost predictability moving forward. Because in many ways, we are funded by the energy industry. The easy answer would be we don't have to worry about cost because energy industry will pay the bill anyway. We all look at it, that's not an acceptable place to be. We are custodians of smart metering. Ultimately, it's the consumer that pays the bill. So how do we drive and hold ourselves account for driving those cost savings in? At the moment, we're scaling. So our costs are increasing year on year. I think the transformation journeys will go through over the next 3 years. And we're starting to see it now. Our cellular journey saved hundreds of millions of pounds over the 20-year life of the cellular platforms we're going to operate. So the next journey will be around our infrastructure costs, showing how we drive down those operating costs over the coming years. It's really, really important to all of us in DCC. As custodians of smart metering, we realise, I talk about being, a regulated and licensed monopoly is a privileged position to be in, but what we're building, it's an asset that's going to operate on behalf of UK PLC. Yeah,
I think there's a couple of observations there. I think, firstly, what you're doing on the supply side of cost, the pricing, it's fantastic as a good, absolutely something to be done. I think from experience elsewhere in different firms, there's a neglect on the demand side. And then, there's a flawed assumption often that all demand is valid and, we should spend cloud resources on. And I think you made some interesting points earlier on around prioritization, and not every single message on your network needs to be serviced here and now, where there are messages that do need that. So that's interesting. But yeah, I think probably, to your latter point there, that the fact that you're building this platform that is going to be highly extendable, and then these new use cases come along with new edge devices, leveraging that network, I think is an interesting challenge there, isn't there, around the future predictability of cost.
Yeah, and Danny, the demand side one's a really interesting one. When you think about at our inception, demand forecast was based around reading meters twice a month. Where we are today, asking a retail energy provider to forecast their demand for the DCC network in 2033, 2035, is probably a level of maturity that they're not prepared for yet. I think we've lived a little bit on, because when the network was built, it was sized to serve 30 million homes. So everyone today thinks, well, I could just use it. There's plenty of capacity there. Give me infinite cash and infinite time and I'll build you infinite capacity, but we will have capacity constraints. So the demand side forecasting is going to be absolutely key for us, where there are gaps, because our users today don't understand where the disruption is going to come from. The challenges of running on a completely renewables-based carbon zero grid will be different in 2035. So us having access to data that we can start to use to predict what we think demand will be absolutely crucial. And then we're going to have those conversations with the stakeholders, whether that's Ofgem, whether it's DESNZ, whether it's all of our wider industry stakeholders, say, well, here's what your demand forecast is, but here's what our demand prediction is based on what we see as an aggregation of everyone, because everyone's got different drivers. Right. And a key part of that, again, it's that stakeholder engagement, being able to have the conversations with, the people that are in the energy industry today, but there will be disruptors that come along and drive growth onto a network. Who would have thought around live streaming of videos to Facebook, what that must have done to the mobile networks when they didn't have any sight of that coming along. I remember they were looking for it
back then. When I was working in a network operator back then, they were looking for what they called the sort of the killer app, and they couldn't see it coming. And
as was I, Danny. I think there was a time, probably going back in time a little bit now, probably 8-10 years ago, which I remember one of the cellular operators did a significant network upgrade to their core, not knowing that Facebook video stream was coming along, and almost within 24 hours, Facebook turned that on, and that capacity was almost gone.
Yeah, great. It's a bit of a left field question here from one of the attendees, so I'm not sure if you can answer it, Mike, but we'll give it a shot. Do DCC work with the power generators to monitor how the dispatchable power is being generated, i.e. green sources, and provided to the grid? I see this as a big step in addressing greenwashing by power generation companies. Yeah,
it's an interesting space. Certainly the establishment of what the NESO is, and the National Energy System Operator in the UK, as sort of evolution of National Grid. Their role really is around the data aggregator, to pull all that information together so they can balance. I guess balance generation and demand is going to be absolutely critical, of which domestic pay is a key part of that. We're seeing their role really ramping up as that sort of building the data sharing infrastructure that enables the generation, transmission, distribution, and consumption. That sort of holy trinity of how that all comes together is going to be absolutely critical to this journey. So we are, we engage with them, we're supporting them, we're engaged in all the conversations around how do we build a data sharing fabric that's right for UK PLC that balances generation, transmission, distribution, and consumption.
Okay, great. And then another question, does any organization similar to DCC exist globally? What are the free learnings you would replicate for DCC in the UK?
In many ways, I like to think we're unique because it makes me feel good. But, there are other organizations, the distribution network, the models around the world are all very, very different. Distribution network operator leads are quite common. Certainly we spent a bit of time with Vector Energy, operates in Australia and New Zealand. Very similar underlying infrastructure models. DNO slightly different lens because they only have to serve the needs of their customers. As certainly within the UK, we have probably one of the most deregulated energy markets. That's created a unique set of challenges, unique set of opportunities. But they're all similar challenges: infrastructure that scales, legacy, devices on the wall, data sharing for the future, customer and consumer confidence around the data being made available. So we have the most complex model, which I think puts us in a great position to be around thought leadership around, if you've got a problem, we've probably been through it and we may have an answer for it, so come and talk to us.
Yeah, I think just on that point you made there, we didn't actually get into it. You could probably do another talk. There's a lot more to cover, but you guys have APIs that you offer up to interrogate that smart meter data, and your customers, the DNOs, can build apps to pull that data, and that's another interesting demand challenge you guys have to face, right?
Well, it's very rigid today, and we very much want to move to more of an API-based sort of infrastructure. The way of connecting to DCC today is very, very complex and very time-consuming. So that's one of the areas that we've got to improve.
Yeah, great. Look, we're almost out of time. I just want to say thanks very much, Mike. Look, at any more questions, just ping them in and we'll follow up afterwards. The other thing both myself and Mike are really keen on, is getting feedback on future sessions that you would like to hear. And Mike, I know you're super keen as well to bring more people into the conversation. So, technology leaders in, not necessarily in CNI, but in other sectors, right? We'd be interested in talking with and having these discussions with, right?
Yeah, Dan, it's really important. We're all on similar journeys. We're all learning lessons, and we don't do enough around sharing the insights we're all gaining, and sometimes trying to use our voice to, I guess, influence the future policy.
Yep. So listen, if there is anyone out there listening and wants to get involved in the next discussion, drop me a line, and we'll pick it up, and hopefully we'll be lining up some more of these conversations in the future.
Yeah, thanks all. Thanks, Danny. Been great.
Thanks, Mike. Appreciate your time. Cheers.